Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. I'm delighted to be joined by Dr. Peter Stone, a globally recognized leader in artificial intelligence and robotics, with a career dedicated to advancing intelligent agents and autonomous systems. We're going to explore how AI is evolving to interact with the real world, from cutting-edge research in multi-agent systems to the challenge of building AI that learns and adapts in real time. All right, welcome to Hidden Layers, Peter.
Pleasure to be here. Thanks for inviting me.
Okay, I want to talk about your research is primarily focused on, multi-agent autonomous systems and robots and things like that. Could you maybe just from a high level describe what multi-agent systems are?
Sure. Yeah. So to start with, multi-agent systems is a collection of agents. So let's start with what it means to be an autonomous agent. An autonomous agent is a computer program that does three things. It senses the environment, it decides what to do, and it takes an action in the world. So it could be a robot. An autonomous robot has to use either a camera or a laser rangefinder to sense its environment, has to then decide what actions to take, execute them, and then the actions that it takes influences what it will sense in the future. And so it's got this sort of closed loop. And so it could be a robot like an autonomous car or a robot soccer player, something like that. Or it could be a software agent, so an agent that bids on eBay or bids in auctions or bids in on the stock market. It has to sense the prices, decide what bids to place, what to buy and sell, and then actually execute those, and then that'll affect how much money is in the bank for the future. And sort of in principle, a person is also an agent. Not we wouldn't call it an autonomous agent, but we also sense, decide, and act. So putting these together, you then can, if you have more than one agent that are interacting with one another, you get a multi-agent system, just as it sounds. So, taking the autonomous car example, a single autonomous car is an agent. You put a bunch of them together driving on the roads in traffic, that's a multi-agent system. A robot soccer player, one that has to, can kick the ball on its own, that's a single agent. You put them together, you have, several, either 5 or 11 on your team. You maybe have some that are opponents. That's a multi-agent system. And as I sort of alluded to, you can also have multi-agent systems that include both robots or software agents and people. That's also in principle a multi-agent system. But and then same thing with bidding agents or software agents or supply chain management agents. Right. Those also become part of a multi-agent system.
Right. All right. I'm glad you brought up soccer because I want to talk about RoboCup a little bit. So to set the table, RoboCup is a competition, goes back to 1997, and it's essentially autonomous robots playing soccer. And the goal, if I understand it correctly, by 2050 is to have these autonomous systems able to compete at a human level and even beat human teams. Is that correct so far?
Yeah. So in fact, I would say emphasize that latter point. Sort of in the same in the chain of computer programs doing better than people at something. Yeah. So chess or Go or Jeopardy or one that I've been involved in, Gran Turismo. These are all things where they've sort of gotten progressively harder tasks or more complex tasks. Soccer would be sort of beyond what we've been able to do right now in terms of autonomous agents besting the very best people at some task.
Right. When I think about robots and the progress we've made over the last 30 years, it's clearly accelerating in a pretty dramatic way. And we were talking a bit ago about when I was in grad school, we built some autonomous agents. They were like little 4-wheel, almost like Lego cars, and we would have a competition just on like a 2D surface. And, it was like watching 4-year-olds play soccer, right? They'd all just kind of clump together. I would say as somebody not working very deeply in robotics at all, I'm really just blown away by the progress we've made recently. It feels like there's been an explosion, maybe even especially last 3-4 years. Could you maybe describe at a high level what you think is the core driver of this real acceleration and progress within robotics and autonomous systems?
Yeah, I mean, it's actually there's not a single thing. Robotics combines hardware which is the the joints and the and the motors and the processors and being able to build the device with the software, which is trying to control the device, trying to get it to walk robustly, to get it decide what to do, to sense. And there's a lot of things sort of swirling around and coming together. Certainly the sort of neural network capabilities in perception and in being able, and in natural language processing have opened up the sensing side of robotics a lot. That you can now and bringing those down to sort of relatively affordable prices, or that can be run on embedded devices.
Right.
That makes a big difference too. And then same thing with the with the motors and the hardware of the robot. Like it's one thing to be capable of building a robot, and it's another to be able to make it at a price point that it can get distributed to a bunch of people, which actually then opens up the possibility for rapid progress on software. If it's if there's only the people who built the robot have access to the robot, then you're sort of reliant on what they can do from a software perspective. As soon as it's broadly disseminated, then there's the whole world's creativity on what can what kind of software can you bring to bear. And so I think there's raw capabilities in perceptions. There's better sort of actuators at lower price points, and then there's just the advances in software and decision making and reinforcement learning and machine learning. All of these are making a big difference.
Do you like, if you break between hardware and software, do you feel like one is more blocking at this point, or are they advancing at both at the pace you need?
I mean, I think if you ask me what's the bigger limiter for having robots being able to beat people at soccer by the year 2050, right now it's the hardware. We don't have robots that can move nearly as quickly and agilely, who can bend it like Beckham, or who can kick the ball, that can and whether that's there's definitely hints that this might be possible within the next 25 years, which is where the horizon we have set for ourselves. And I think that's the bigger source of uncertainty for me. But the software is very hardware dependent as well. So I think we have some great software that sort of milks as much as we possibly can out of the robots and hardware that we have available to us. But it's not clear that same software will be the right software for the next generation of robots, or the ones that are agile enough. And so it's there'll certainly be some building on the knowledge we have now, but there'll also be sort of new things that are needed, and because they do go hand in hand. And some of the biggest problems that you have with current hardware that you try to solve with ingenious software solutions can just be completely erased by better hardware, right? So I think the bigger blocker just is the hardware, because that has to come first.
Has that been the case for most of your professional career, or has it sort of oscillated where, because I would have said 10 years ago, the hardware is outpacing the software, and clearly that's not the case anymore.
I mean, I don't know. I'm a little biased because I focus more on the software. I'm more of a computer scientist than an electrical or mechanical engineer, and so to me, the software is where I have my is the locus of my creativity, and where I've always been put my thinking. So I find it easier to think about sort of advances in software, and I'm counting on my colleagues, on other people to come up with the advances in hardware. So it's always felt to me like the hardware is the bigger limiter, and then I'm going to write whatever hardware that's given to me, I'm going to write the best software I possibly can to like I say, milk as much out of it as possible. That's sort of the way I tend to work. But there's I think there's others who would just say, oh no, writing new software is is really hard. Let's just throw away the hardware and build something. Let's focus on the motor. So it depends on perspective. It depends on where you're coming from. And I don't think all my colleagues would necessarily agree with me. But for me, throughout my career, it's always felt like the hardware is what we really need, and we'll do our best to make the software sort of
do what it can given the hardware. Okay. I'm really curious what, over the last 5-10 years, AI has changed so much. I mean, so dramatically. During that time, what has shocked you the most? Like an advancement or a technique, or maybe it's even the lack of progress in some areas. Is there anything that really stands out that you think back and you go, I did not anticipate that?
Yeah, I mean, there's no question that the biggest sort of scientific surprise of my career, and it might be of sort of all of our lifetimes, is how amazingly powerful it is to just do next word prediction for large language models. I mean, I think much of the world, it seems like a sudden thing. I worked on neural networks as my undergraduate research project in the 1980s. I mean, and people have been working on neural networks before then. Neural networks are not new, and we knew that they had some capabilities, but that they would just blow out of the water the sort of existing algorithms for computer vision, for natural language processing, and frankly also for game playing. The result for Go, for AlphaGo, was also very surprising. But I think they're all sort of stem from this same surprising fact, and that neural networks are just as powerful as they are when you give them the right amount of computation, data, and just let them go to town. And it's really the capability of the large language models, and then the expansion to vision language models and things like that. But that has been shocking, and it's it's sort of destabilized everything in many ways. It's sort of somewhat frustrating that we still don't understand why and how they work, but they do, and so there's questions of how to make them work better. There's questions of given that they work so well, what can we do with them? What are their implications in robotics? What are their implications in small businesses? And what are the startups that are going to happen? What are the implications for healthcare, for everything? I mean, it's I think so. This is doesn't come as a surprise to anybody, I'm sure. It's sort of burst onto the scene, and it is changing. It has changed the world. It is changing the world. Mm-hmm. Now, at the same time, as shocking and as surprising as it was and has been, it's also still overhyped in the sense of like the expectations for what they can do is still beyond what they should be, and that I think is harmful, and that's something that I think is important for us to sort of keep some perspective. And I think that there is a little bit too much of sort of jumping ahead to to what people started calling AGI and then ASI, and then it's a really exciting time for artificial intelligence, but there's still discoveries to be made if we're going to get to what people are claiming is going to be possible within a year or two. That's overblown.
All right, you said a couple of things there I really want to follow up on. I agree deeply with the perspective that the fact that sort of next word prediction can lead to these types of amazing emergent behaviors is the single most shocking scientific discovery of the 21st century, in my opinion. And I feel like, so on that front, the news out of DeepSeek recently, and there was a lot of a sort of a market effect around sort of the relatively inexpensive cost to train it. I think that was a sort of a complete miss on what's interesting. What's really interesting to me is that they took a base model that had, some pretty strong capabilities, gave it some cold start, chain of thought examples, trained it, and then sort of, this four-stage training process, but one of them just involved reinforcement learning at scale. And, in the paper, they describe it, the model started having these aha moments, right? It all of a sudden, instead of just generating output and going directly to the answer, it would say, well, wait, I've output a contradiction. Let me go back and think about that. And what's really got us all excited about that is if we can, build on the previous generation's model and use those and things like verifiers to really bootstrap up these models and get them to sort of reasoning capabilities. I think this is going through all of our heads is there an element here where we have almost sort of enabled recursiveness, where now the models, if they can think about thinking, well, you can certainly think about thinking, and have we unlocked some new approach, or as a lot of people think, no, this is the illusion, right, of progress. And there's a little bit, maybe we're one more rung on the ladder, but it's not really going to lead to that much more advancement. Autoregressive models are fundamentally a dead end, which I don't believe, but I'd love to hear what your thoughts on that.
Yeah, I mean, everything's a dead end in the sense of there is a limit to what you can do with it, right? So the question is, where is that dead end going to be? Right. The way I see this sort of this what people are calling reasoning is to me actually an indication that scale, like just next word prediction and scaling up does have a limit. And what's happening now is we're taking those systems that were trained just on next word prediction and putting them into what you would now call, and what we would call many years ago, and is essentially the same thing, an agent architecture. It's now like an autonomous agent. It's got, it has different components. It has a thinking fast component of like the sort of, the neural network. It's got the thinking slow component, which is essentially a planner. It can use Monte Carlo tree search. It could use reinforcement learning. It can, but something that does more of what we think of, in the system 1, system 2 of Daniel Kahneman's book, more of the system 2 kinds of things. And that's, so an agent architecture from back when I was a PhD student, things like SOAR and Prodigy and Actar and things like that, have these different components. They have different modules for perceiving, for language, for reasoning, for planning. And that's, I think, basically is what's coming back. And to me, that's really exciting because, what's happened in the world of AI because of this, the power of neural networks, is that there was sort of a everybody jumping on the bandwagon kind of thing, where people said, okay, neural networks work, let's abandon everything else and let's see how far you can go with just scaling up, which is a sensible thing to do. We want to see how well the methods can work on their own. But it risks throwing away the baby with the bathwater in some sense, that there has been a lot of great progress in artificial intelligence, in planning, symbolic reasoning, in probabilistic reasoning, graphical models, Bayes networks, all these kinds of things that, to me, retain value. And it's sort of ironic, actually, because there was a time when neural networks were seen as the low odds thing, that this isn't going to pan out, and people who were working on it were like, well, they're going down a dead end, but let's keep it alive. Let's not kill neural networks. Give it a chance, and let's because you want to keep a diversity of research approaches. And it turns out it does really well. And then the reaction isn't, okay, that's a win for keeping a diversity of approaches. Instead, the reaction is, okay, let's throw away everything else and do just this one thing. And to me, that's actually quite harmful for progress in the field. And so it's to me, a great thing that people are bringing back, and in some cases rediscovering things that we've known for many years without sort of keeping the historical context. But that's not a new thing that happens throughout science. It's to me exciting that people are recognizing now that it's important to people are calling it agentic or agentifying, but this is bringing back things that have been well studied, and now exploring how can they be rejuvenated in a world where there are these neural networks that didn't exist when they were studied in the past.
Right. So you brought up agentic AI, very closely related to what we're talking about. Most people today, when they talk about agentic AI, they're mostly talking about sort of like software systems online, doing things like automatically making restaurant reservations or something.
Tool usage.
Tool usage, exactly. To what extent do you think in the short term we're going to see success in pushing on this idea of using the reasoning models? Let's just use that term, reasoning models, as essentially the planning system or the brain for autonomous agents that may be separate from their perceptual system or other aspects of their almost like limbic system, for lack of a better term. Do you think there's inference, latency issues and stuff like that, but do you think there is much promise in exploring that direction?
I think there is. I think, but again, we should also recognize that there has been a lot of progress in, symbolic reasoning in planning systems. And so, I think these reasoning systems that are doing chain of thought and seeing what you can get by having a neural network sort of, go think step by step, right? It's interesting to see what they can do, but there is also the alternative approach of using the language model to translate a word problem or a reasoning problem into the formal language of a planning system, and then use a planner that's guaranteed to be correct, right? So there's still no guarantees about any neural network, either a one shot or a reasoning one. It's they're coming up with answers that are useful, but still need to be checked. There's sort of hallucinations, as they're called, that happens both through the reasoning systems and through the just next word prediction, the one shot models. But we do have methods that can that are provably correct in reasoning. And so, the analogy, I'm not the first to make this, but, it's sort of like, would you use a language model to do arithmetic, or would you have it like translate the problem into a format that a calculator can do and then use a calculator, right? And there's no reason to have a language model do the arithmetic. I mean, unless you're just studying whether it can or not. But we know that the calculator is going to be correct, right? So if you're going to try to multiply two large numbers, don't ask the language model to do it, even with a reasoning process. Ask a calculator to do it. And I think, there's that same thing. There are problems which are better solved by AI planning methods, and translating them into that and making that a part of the agent framework or the agent architecture. And I think that will always be the case. So, but then there may be systems that there may be problems that are hard to translate into that language, and so then you want to also have this capability of thinking step by step, getting more correct answers, being able to to reason. But it's still not. Be careful about anthropomorphizing. It's whether we as soon as you start saying it's thinking and then thinking about thinking, people start projecting things onto these models that they're not really doing. Yeah,
and I totally agree with that. I prefer to think of it more as recursing, right?
Yeah.
So I was lucky to have your amazing colleague Scott Aronson on Hidden Layers last year, and we were talking about his work at OpenAI on around alignment, and we were discussing is it even feasible to align super intelligent systems, and he he's got this great metaphor where he talks about, orangutans, you've heard this where, orangutans invent humans and they're like, this is great. We can have them do stuff for us. All we have to do is just make sure the humans stay aligned with our orangutan values. Right. What are your thoughts on that? You've explored, AI and ethics in a deeper way than I think most AI researchers, and you've really put a lot of time and thought into that world. What are your thoughts on the future? And let's just say the next 25 years, because I think we can barely see 5 years in the future, let alone 25, 50. But what do you see, and are you optimistic around alignment of sort of super intelligent systems?
Yeah, so I think first of all, there's confusing terminology that's being thrown around that I think I'd like to first separate a couple of things. So, people sometimes talk about AI ethics and AI safety as being different things, and there used to be sort of clean usage of those words. They've started crossing a lot, but it's what people usually have meant or traditionally have meant of when they say AI ethics is sort of the short term, what I would normally think of as safety, don't inject bias, don't, if you're, being used to patrol a region, don't shoot the person, just, without a human in the loop or something like that. Those are like the nearer term things, and somehow those got called AI ethics rather than AI safety, and then AI safety got used to be this alignment of super intelligent. Don't destroy the world. Don't Stuart Russell's analogy of don't tell it to make as many paper clips as possible, and then it makes a paperclip factory by killing all the people to get all the resources, because that's the best way to get all the resources. So somehow, I don't like this terminology. I think it's AI safety should be the sort of the near term thing, and then alignment is a good term for what sometimes people call safety. So you're asking more about the alignment side of things here, and I think it's a very interesting topic. I do research on that. I publish. I've been publishing papers on how do we come up with reward functions that if a reinforcement learning agent optimized them would do what we really want them to. This is work that's often a lot of it's led by my colleague Brad Knox, who actually was one of the first to do reinforcement learning from human feedback back in 2008.
That's
right.
It
wasn't called that, but that's essentially what his PhD thesis was. And I think it's a great intellectual exercise, but I think it's premature to be thinking about it from a how do we align a hypothetical super intelligence. We don't really know what that would be like, and so I think there is harm right now in overemphasizing that in the sort of public sphere, the policy sphere. That's not really what we need to be concerned about right now. There are no AI systems that are by themselves going to sort of destroy all of people. Now, there are AI systems that people might misuse, and people could use as people could weaponize, and that's that is a real concern. But that's the same kind of concern as any technology. Airplanes are fantastic, but they can also be used as weapons, and right. So the AI models are fantastic. They can also be used as weapons. That we should be worried about. But it getting out of the cage and then sort of somehow deciding that people are the enemies, to me that's science fiction. And to it may come up someday, but when it does, or if it does, it will be with AI systems that are so unlike the ones we have right now that the thoughts the thinking we're doing could be valuable and from an academic perspective and laying the groundwork, but it's not time to be passing laws or policy
I totally agree
about
with
these
that.
kinds of things.
I completely agree.
And it's distracting to the things that really matter. The AI, the near term, what I'm saying is sort of safe AI, should be the focus and is crucial.
And I'm torn about this because, I'm one of those people, like you've been working in AI for decades, and I took AI safety and AI ethics pretty lightly in the beginning because it was mostly a question of this stuff doesn't work. I'm just trying to get my little project to do something. You guys are worried about stuff that are maybe hundreds of years in the future. But, as these systems have become more and more powerful and they're becoming sort of more and more deployed, I'm also sympathetic to the perspective of like, well, you can't wait until we have these super intelligent systems to think about it. But I'm very...
So it's to be clear, I think, we should be thinking about it. But there's a separate and doing research on it. It's fascinating, but it should be it's still an academic question from my perspective.
I agree.
And I think to emphasize the point you said, I think when I was a student, most computer scientists were computer scientists because they didn't want to take humanities and social science classes, and they wanted to be programming and solving puzzles and whatever. I think that ship has sailed. We're now at a point where first of all students, regardless of discipline, need, starting in really high school, maybe even middle school and elementary school, need to be learning about artificial intelligence. It's like, it's like reading, writing, or, arithmetic. It's just it's important to be AI literate. And so I taught a course at the university last semester called AI literacy, or the essentials of AI for life and society, designed for humanities majors and music majors, because I think everybody needs to learn about AI. And then also all AI students and computer science students now are at a point where they need to take ethics classes and social science classes and humanities classes to think about what, not just what can they do, but what should they do, because we are seeing that AI systems are getting out there into society, having really real implications, real effects, and some of them fantastic, and and some of them not so good. And so it's important to think ahead before deploying something, not just to throw it out there and see what happens and then try to fix it, but to to try to think ahead about what are the ways I can deploy this technology such that it's more likely that it will benefit, be used for good than for bad. And that requires this kind of thinking that it is not a traditional computer science type of thinking, but it's important.
I couldn't agree more with that. And your point about it's not the right time, I think, to start passing laws around systems we don't really even understand yet. We need to be highly collaborative, and I think we need to be thoughtful, but we need to work together, I think, in a really sort of broad way as we understand these systems, because we don't know. I mean, foundationally, I don't think I would work in AI if I thought there was just an enormously high probability that these systems would become, completely self-autonomous and competitive with us in a way that was, existential, right? I think that evolutionary and selective pressures have to come into play for certain things like that to occur, and I can see a world where that's not the case. So I'm still super, super optimistic, but I also, like you've been doing this long enough, I'm like, well, it's hard to predict what's around the corner.
No, I've been, Scott probably said it when he was on here, Scott Aronson, and he says it often, like, I used to think this would never pan out. I was surprised, and so now I don't know what I'll be surprised about in the future. And there is something to that. Like I can't. None of us has a crystal ball. We can't predict where things are going to go. It does make sense to prepare. And I don't get me wrong. I don't want to be. I'm not saying that there should not be laws about artificial intelligence. There should be. I think there are regulations that are needed. It's just the locus of those. The focus of those should be on the way it's used in society today, not like how can we prevent it from getting out of the box, so to speak.
Right. Totally agree. Okay, I'd love to finish up with getting your thoughts on really kind of two things. The things that what have you been most excited about recently, and just a little bit of a prediction, like where do you think we're going to be in 2030? And I want to kind of put these questions together because I think they're really, really, really coupled. If you'd ask me in 2020, well, we have AGI or ASI, however you want to say it, by 2030, I would have probably hedge my bets really strongly. Things feel like it's really possible now. It's difficult to say, but I would certainly say it's much, much more likely than it was 5 years ago. And that's predicated on a lot of the things that we've talked about today. So just if you had to pick one thing in the last few years that you're most excited about, and then where do you think we're going to be in 2030? I mean, just from a sort of a capabilities perspective, I'd love that. Hear about that.
Yeah, I mean, I think this is where there's there's things that everybody thinks are closer than they are, and I think like my whole research career, people have said autonomous cars will be everywhere in 5 years. 5 years is always the horizon, and it's like people used to say autonomous cars are 5 years in the future, and they always will be, right? And so
Right.
I think there is some of that going on. That there's so I think the capabilities that are more within my sights that I think are exciting. I think where we started, the progress in robotics, I think there is people are sort of the cost is going down a lot, which is allowing them to move out. Both capabilities of humanoid robots. There's some really beautiful humanoid robots that have been introduced recently, and that are getting to a point where they can get distributed and people can start playing with them. The capabilities of manipulation is improving. There's still a long way to go with dexterous manipulation. Robots being able to pick things up, fold towels, unload your dishwasher, things like that. And doing it, period, and then doing it in a cost-effective way that can actually allow for it, that to be broadly accessible. I think we're still a long ways away from that. There will be a moment when that it happens. It's hard to predict when that'll be. Hardware always takes a lot longer than software, but it's it's the kind of thing where when smartphones were introduced, then you could immediately you couldn't remember a time from when you didn't have a smartphone.
Yeah.
There will come a time. I don't know if it'll be in my career or not. It could be in 5 years. It could be in 30 years or 50 years when robots will be capable and affordable enough to actually be useful in your home beyond vacuuming. That's a lot of my research is trying to be a part of that. I think that it's a huge challenge. I think there's still lots of things to make that, lots of discoveries needed to make that happen. And so I'm excited about that. And I am also, as the other place we started was multi-agent systems. I've been focusing a lot on a particular capability of multi-agent systems that I call ad hoc teamwork, which is the best analogy for it is my ability or our ability to go and play a pickup game of soccer, right, with people I've never seen before, even who I don't speak a language with. Like, I can go to a different country, jump on the field, and since we all have this common experience, we can immediately form a team, even though we've never practiced together. And people can do this, right? If there's a horrible accident on the road and there's a bunch of bystanders, like people strangers who've never seen each other will jump into action, and one will go try to rescue the victims, and one will call 911, and one will direct traffic, and they'll form a team without having worked together. And I'm fascinated by that ability of people that has not really been a huge focus for autonomous agents or robots yet. Usually, it's that a team gets programmed together to be a team, and so that's something where that's sort of one of my passion projects is trying to get this. You could think of it as emergent teamwork or like on the fly teamwork. So I'd say we've covered them in this conversation, but I'm super excited about trying to push forwards robot soccer as a challenge for trying to get to superhuman capabilities. I'm really excited about the challenges of general purpose service robots that could go in your home and do many different things, and then this ability to do on the fly teamwork, and at the core of all of those, the reinforcement learning algorithms that I think can make these come from their own experience, from learning from mistakes, from improving over time, and so that's sort of where that's what I'm excited about as where things are going, and it's also where I'm putting my energy.
It's such a amazingly wonderful time to be working in AI right now. I mean, we're making progress on every one of the fronts you just mentioned.
Yeah, exciting, but also challenging. Like, sometimes, when there's so many people thinking about the problems, it's a race to get to the next one. And I sometimes long for the early '90s when I knew the whole community of people who were working on what I was working on, and I could, there'd be an interesting paper or two that came out every few months. Now it's a full-time job just to keep up, and that can make it exciting, but also challenging in many ways. It's also hard for students to find sort of their foothold, and so in this new world. So there's good things and there's bad things about it. I think it is probably a part of a cycle. We probably will go back to something closer to the way it was in the in the past eventually. But now with a whole bunch of new tools in our toolbox. So we'll see where it goes. I think beyond pushing new capabilities, there's also a whole bunch of untapped potential with the current capabilities.
Yeah, I agree with that.
What can be done in startup companies, in sort of siloed applications, and so the next 5 years will probably bring a whole bunch of more maturity to how the technology can be used. And to affect our real day-to-day lives. And to me, that's fascinating and thrilling.
I couldn't agree more. I agree. I think the next 5 years, we're really going to have some watershed moments within the sort of autonomous systems world. It's going to be amazing.
And you don't even need a lot of new capabilities for that. That's going to happen with the capabilities that already exist now.
Exactly. Well, Peter, thank you so much for coming on. This was fantastic.
My pleasure. Thanks for inviting me.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.